Good afternoon. Um, I thought I would take the opportunity here, since you guys are not in the room, to talk a little bit about alcohol. Whoops, let's try this. Alcohol reactions. This is going to be kind of an overview of what we are going to be talking about on Wednesday, Thursday, Friday. So if you watch this video, I think it'll make those days a lot richer. Okay? So this is what we're talking about, and this is kind of the last content piece that I want to cover with you guys. You have this table, and this table kind of goes through the different types of reactions that alcohols are characteristic for. So I'd like to work through this with you. If I annotate this at all, feel free to do the same to yours. The first type of reaction is going to be if you take an alcohol, and let me put, how do I want to do this? Okay. If you take an alcohol right here and you react it with sulfuric acid in the presence of heat. Another substance that would work here is H3PO4, phosphoric acid. You'll see it's either phosphoric acid or sulfuric acid, but the important piece of this, there's got to be some heat. And we'll talk about how much heat here. The product is an alkene and water. Now, does that look familiar to you? Probably not. The key word here is elimination. This is what we call an elimination reaction. You are eliminating the hydroxide, and what you're getting out of it then is a double bond, or an alkene. So in a sense, we're calling it dehydration. You're removing water. And we're going to be using a couple of terms here. One is called an E1, the other is E2. These are two different types of mechanisms, and I'll talk about those a little bit towards the end of this. So, elimination. That really looks a lot like, if I started with an alkene and ended up with an alcohol, we used to call that electrophilic addition. And that this process is actually a reversible process for you. So, interesting, huh? The second reaction type that we'll end up talking about is a substitution reaction. And this is where I take an alcohol and a halide. So we've got our alcohol here, it's butanol, 2-butanol, and I'm taking it with a, what do I want to call this, a binary acid, either hydroiodic acid or hydrochloric acid or hydrobromic acid. And what you get, again, is water, but you notice where the OH was here, there's now a halogen. And so we are substituting a halogen for the OH group. And here we're going to see terms like SN1 or SN2. And this stands for nucleophilic substitution, which is, we've been talking about in our reactions up to this point, electrophilic. This time we're looking at a nucleophilic. So it's going to be the substituting of a nucleophile for our leaving group. So substitution is the second type of reaction. Third type of reaction is oxidation. And oxidation is the addition of oxygen or the removal of hydrogen. And so what you've got here is a primary alcohol. We're oxidizing it. Usually you're going to see one of these things. If you see anything containing chromium or manganese with oxygen, that's kind of a dead giveaway that what you're doing is oxidizing. And the product is going to be a little bit higher in the ladder. You're going to get an aldehyde, and for primary alcohols here, we're going to see that there's also a possibility to go all the way to the end, which would be producing a carboxylic acid. If I have a secondary alcohol, notice the difference in the product. Because the carbonyl does not form at the end, it's going to form wherever the OH is. The option that we have here is we get a ketone. And then for a tertiary alcohol, if you look at this, if we try to oxidize a tertiary alcohol, there's no reaction. And you might scratch your head on that a little bit, but if you think about it, there's no hydrogen on this carbon to remove. It's a naked carbon, so to speak. And so there's no reaction. We can't oxidize this any further. So, a couple other reactions that I'll mention, I'm not going to talk a lot about. If you take an alcohol and combine it with another alcohol, you remove water and the product is an ether. This is what we call a condensation or dehydration reaction. Again, anything that removes water, what you're getting is dehydration. And then the final one here is taking an alcohol and an acid, and this produces an ester. And this is a type of reaction that we call esterification. And I'll show you a couple of examples of this in class. And just briefly, I wanted to talk with you a little bit about this SN1 and SN2. If you watch the Khan Academy videos, he's going to mention this, and I wanted you to hear it from my mouth also here in the video, and I'll also be talking about this in class. An SN1 mechanism. What we have here is a tertiary alcohol. This is, you could be calling it tert-butyl alcohol, but the carbon that the OH is on is a tertiary carbon. And the SN1 mechanism, the key piece of this is that the carbocation is going to be formed. And the carbocation is what you see down here on this third diagram. But just to walk you through this, the first step is protonation, and that's the key word here. Protonation is we're adding a hydrogen to the hydroxyl. And what that allows to do, if I have a water group here, this water group is what we are going to call a leaving group. It's a very good leaving group, and that's exactly what happens. This carbon-oxygen bond here cleaves, and the water is gone. That's where you see it right here. And what's left is a carbocation. This bromide ion, which is a nucleophile, attacks that carboion and forms the bond. And that produces your alkyl halide. So this is what we call an SN1 mechanism. And I want you to think about this and look at it very carefully, because here is the SN2 mechanism. And you'll notice that this just has two steps. Again, what we're doing, we're protonating the water. So the addition of water here makes a water group. And that, again, that's a leaving group. But what you see happening here, this next step, when this leaves, this bromide comes in, and this is simultaneous. It happens at the same time. What that means is that we're not getting a carbocation here. And the reason being is that what we're looking at is a primary carbocation that would be formed in this case, and that's not a very favorable thing. And so they have a different type of mechanism that works here, and this is called an SN2. And the words that we used in the elimination reaction, E1 and E2, you're going to see the same or a similar type of mechanism going on here. So we'll talk about this in class. I wanted you to see it. We'll see if we can make sense of it. Okay? Thank you very much.